Hello, everyone, and welcome to Biohackers Lab. I'm your host, Gary Cohen, and on today's episode, I have Greg Potter. Greg helps a range of individuals feel and perform better, from elite athletes to CEOs to people who have mood disorders. Since he did his PhD on the topics of sleep, nutrition, and metabolism, Greg spends much of his time helping individuals sleep better, but his interests are much wider than this subject alone. Highlights of his career so far include coaching a sprinter to 4 gold medals in their category at the European Championships, having his research featured in dozens of international news outlets, including the BBC and Reuters, working with the US Naval Special Warfare Command, and helping to prepare 2 men break the Atlantic rowing world record. Greg, thanks so much for coming on.
Pleasure. Good to be here.
Yeah, just reading your bio there, I'm super excited to get chatting with you today all about health optimization, and particularly when it comes to our body clock and sleep.
Yeah. And I was saying to you before we started recording, the bio is so self-indulgent. So forgive me, I promise that I'm not as much of a jerk as I might appear based on that.
No, you don't sound like a jerk. I mean, it's. I think people are going to love it now because you've got a wealth of experience, and I'm looking forward to finding out the actionable tips that you've discovered along your way, from research to actually implementing it with others, and some famous others, it sounds like. So I wanted to get you on because you're going to be talking at the Biohacking Congress, which is coming up actually now, I see, next week from when we're talking in London. And your subject matter that you specialize in is from sleep, nutrition, and on metabolism. So my first question to you is, how do you start to help someone who's got a broken body clock or broken sleep schedule? Where do you even begin?
It's a very good question. You begin with an interview in which you cover things like their medical history, because sometimes sleep problems might arise from medications that they're taking, or some sort of underlying genetic condition, or some sort of other comorbidity. So, for example, quite often mood disorders will contribute to sleep problems. But then during that time also, you'll find out about things like when the person's sleep problems first began and some of the behaviors that now perpetuate their sleep problems. So, for example, maybe the inciting event was some sort of very stressful event in the person's life. Maybe it was the passing away of somebody who was close to that person. And as a result of that, they became quite down and quite anxious too. And now they experience some sleep difficulties. And in order to overcome their sleep problems, they basically spend more time in bed trying to get sleep at any opportunity that they can. And they start sacrificing social occasions in order to try and get more sleep. And what happens is they start to spend more time in bed awake, and their brains lose the association between their beds and being asleep. And so in that instance, what would be very useful for that person would be to try and reestablish that association between the bed and sleep. And one of the key things for most people is something called stimulus control of behavior. And the idea is very simple. It's just that certain stimuli predictably lead to certain behaviors. So, for example, if you were driving and you're approaching a red light, then you would probably reflexively put your foot down on the brake. And in the same way, when people have difficulty sleeping, just the bed alone can cause them to feel quite stressed, especially if they've been doing lots of wakeful activities in it. And they therefore need to retrain their brains to associate it with sleep. And basically what that means is just saving the bed for sex and sleep only. And if they're struggling to sleep, or if they're not currently sleepy, getting out of the bedroom, doing something relaxing elsewhere, for example. So once you've got an idea of some of those behaviors, you'll also look at things like sleep hygiene. So there are obviously lots of different components of that, from things like the times at which people eat, to their use of stimulants, to their exposure to light in the evening, to some of the activities that they might do pre-bed. So perhaps, for example, they can only exercise quite late at night. And if that's very high intensity exercise, then there's a chance that could interfere with their ability to sleep. And also some other things which might seem slightly more esoteric, such as the timing at which they take certain medications, for instance. And you might also get an idea of their sleep related thoughts. So it's common for people who have sleep difficulties to have lots of negative sleep related thoughts and an attentional bias to sleep related cues. And you might not start necessarily by focusing on helping people with some of those sleep related thoughts. That typically comes a little bit later in therapies that are used to help people sleep better. But those are some of the main factors. And then alongside that, it's just useful gathering as much information as possible about the person's health. So, for example, maybe somebody has a wearable device and that will give you some idea of their regular sleep wake patterns. If not, then you can simply ask questions related to that. And there are lots of dimensions to sleep health. People often focus on things like sleep duration, but actually, high quality sleep is about much more than sleep duration alone. So, for example, sleep timing seems to be important at the level of the individual. The variability of sleep, both in terms of its timing and duration and continuity, seems to be important. Sleep continuity, so how broken up somebody's sleep is critical to certain health outcomes. And then also how well somebody feels they sleep, as well as how alert they feel during the daytime or other dimensions of sleep health. And all of those things independently predict certain health outcomes and actually seem to predict the risk of somebody passing away from any cause. So those are some of the broad things that I typically focus on just during that initial sleep period. And then after that, it's really a question of focusing on the strategies that seem to be most important for the individual in order to improve their sleep, but doing so in such a way that they can actually sustain those changes. Because I think much of the time people actually know what they should be doing to improve their health or to improve their sleep. But the thing they struggle with is actually enacting those behaviors. And much of the time that relates to things like their environments, because lots of things influence our sleep, from the actual built environment, so our bedrooms themselves, the beds, the light environment, all of those different types of things, to the neighborhoods in which we live. People who live in quite rough neighborhoods where there's lots of noise and perhaps lots of light at night will be more likely to experience sleep difficulties than people who live in more affluent areas, which are perhaps more relaxed and peaceful. And then also, we, of course, sleep in an environment where there are lots of other people. So most adults share a bed, for instance, and that type of thing will influence somebody's sleep. And then we have social obligations and work and so on. So really, it's just trying to create a complete picture about somebody's life and all the factors that can influence somebody's sleep, but then to not overwhelm somebody with a number of different things that they could change, but instead to structure things sequentially and systematically in a way that supports their ability to sustain these changes over time. And typically, actually, the first things that I begin with people when it comes to improving their sleep, and I typically help people who have insomnia specifically, because I'm not a sleep medicine specialist, I'm not a medical doctor. So it's not as if I help people who have restless leg syndrome or hypersomnia or some of these other sleep disorders or narcolepsy. But typically, actually, we begin by focusing on what I mentioned before: stimulus control of behavior, perhaps some changes to sleep hygiene, although often people who have insomnia already know quite a lot about that subject. And then over time, we can start to move into some other therapies. So specifically something called sleep restriction therapy, which we can come to later, and also some cognitive therapies to help people address their sleep related thoughts too. And then we'll track their sleep too. So hopefully from that initial interview, I'll have some idea about how the person is sleeping on a regular basis. But then typically for the first 2 weeks or so, I'll have somebody keep a sleep diary. And in that sleep diary, they'll just record things like the time at which they went to bed, the time at which they tried to fall asleep, the time at which they woke up in the morning, the time at which they got out of bed, how many times they woke up at night, all of those types of things. And then we'll plot that over time. And that will give us some indication of how they're sleeping at baseline, and then whether the changes that we've made to their lifestyle are positively or negatively affecting their sleep.
Yeah. So the big thing I'm getting out of there is personalization of sleep is important. So it's like most things that we talk about on this show, where you may have general recommendations for a health situation, health optimization, but at the end of the day, there's so much nuance involved per situation, and especially sleep. I love the idea of that stimulus control, because yeah, that association that people could have where it's so negative that I lay down and it's going to take me forever to fall asleep, or I didn't have a good night's sleep in that room or on that bed or on that pillow, and then that negative thought cycle happens, and then it can perpetuate, and then you end up just with bad sleep. So and what you were just talking about there also with the sleep diary too, it sounds like there's a big difference that where you don't want people just to go lounge and relax in their bed for too long before they go to sleep. So don't just sit there and lay in bed for an hour or two watching TV or something, because that's actually not, you're creating a bad association already by building that habit in, are you?
Yeah, exactly. And actually, it's interesting that you mention watching something in bed, because I think that's, for some people, a particularly problematic behavior, using devices generally. For some people, it's fine. And something to mention is that if you don't already have sleep problems, then spending a little bit of time in bed, so for example, reading shortly before you go to bed, is likely not a big problem. But for people who have developed sleep issues, sometimes the things that they need to do differ from other people. And so to go back to devices, there are a few different ways by which they can disrupt your sleep. So if we think about watching TV, for instance, then one of them is exposure to artificial light. So we have these specialized cells in our eyes, and they detect light, and they then send information about our patterns of exposure to light back to a structure in the brain, which is colloquially called the master clock. And then this master clock relays information about our light environment as an indication of whether it's daylight or nighttime to the rest of our bodies. So in this way, if we expose ourselves to artificial light at night, then we're effectively telling our bodies that it's the daytime, and therefore to engage in daytime activities. So by exposing ourselves to light at night, and blue light specifically, or short wavelength light, green light has similar effects, will tend to delay our body's clocks and therefore delay the time at which we fall asleep. But then that type of light has independent alerting effects too. So that's one mechanism by which that type of behavior can disrupt our sleep. Another is that the content is often very stimulating. So if we're watching something which is particularly engrossing, then that can get our minds racing. And another is just that when we watch that type of content, often people lose track of time. And rather than sensing our own internal signals of how sleepy we are, they tend to instead just go by how far into an episode they are. So if they're binge watching something on Netflix and each episode's an hour long, then they think, well, I've got 25 minutes left of this episode, so I'm pretty sure I can make it to the end of those 25 minutes. When actually, if they paused for a second and took a moment to identify how sleepy they are, they might think, yeah, now's the time to go to bed. So that's another mechanism by which those types of behaviors can contribute to sleep problems. And that's TV, but then there's plenty of evidence too that smartphone use can be particularly problematic. And one of the things that I routinely get people to do is to remove their phones from their bedrooms. So they're just not allowed their phones in their bedrooms, because what can happen in insomnia, for example, is people can use their phones shortly before they go to bed. But then if they wake up at night, they'll lie in their bed scrolling through their social media feeds or what have you. And one of the issues with that, beyond stimulus control, as we discussed, is that because social media can be so engaging to some people, they can effectively condition themselves to wake up at night in anticipation of getting that type of rewarding stimulus, if that makes sense. So getting phones out of bedrooms is definitely a good idea for people who have sleep issues, as is not watching an iPad or TV or anything like that. So I think that's a key behavior for lots of people. And I also think that in recent years, with the advent of globalization and whatnot, that type of thing is increasingly a source of sleep difficulties for lots of people.
Yeah, I'd agree. I mean, I'm going to have someone coming on the show, hopefully talking about dopamine fasting, which is a new thing in Silicon Valley and San Francisco. But what you're talking about there too is that dopamine fix, that that reward signal that comes from scrolling through your social network feed, be it Twitter or Facebook or whatever. And I think probably that's where the world is evolving now, where maybe people don't actually sit there and watch TV in their bedroom because they don't put a TV, but they still have a device that either you can watch YouTube or scroll through your social media. And it's interesting that, you could end up preconditioning your brain to want that reward signal and wake up every so often through the night to sort of get a hit. It's like having a cup of coffee just because you feel you need it.
Yeah, and I wasn't familiar with that term, dopamine fasting. I like that, but I've read some of Cal Newport's work, and he's written a lot about digital minimalism, which I guess has caused a bit of a stir in Silicon Valley. And lots of people have tried his protocol, this sort of 30-day period in which you try and use technology only for things that are absolutely essential. And that type of approach hasn't been studied in relation to sleep, but my guess is that that will be very good for lots of people's sleep. So I'd be interested in the person who you're interviewing and that person's opinion on how that might affect sleep and what his or her experiences have been.
Mm-hmm. And so outside of devices, I know a lot of listeners to the show love nutrition and diets, of course. So a large proportion, so you're aware, probably come from the low carb, ketogenic, or even now the carnivore community.
Mm.
What effect do you think their types of diets could have on the quality of their sleep? So do you think that going a more low carbohydrate or ketogenic route could improve someone's sleep, or could it have an adverse effect?
Yeah, I had a feeling this question would come up, and I haven't actually spent much time prepping for that question specifically. But it's a very interesting question. And I'll preempt my answer by saying that there simply hasn't been much research on that subject specifically. So, for example, if you look at the research on the ketogenic diet and sleep, then much of the time it's simply, well, we administered a ketogenic diet to these people who have widespread metabolic dysregulation. So maybe they have metabolic syndrome or type 2 diabetes. And as an afterthought, really, they administered a questionnaire to assess sleep quality. So, for example, the Pittsburgh Sleep Quality Index is often used to that effect. And some of those studies that have looked at whether the ketogenic diet affects sleep have reported that it positively influences sleep quality. But of course, those diets have also reported that the ketogenic diet results in weight loss. And if you have somebody who is obese and they lose weight, then most aspects of their health improve. And obesity itself can contribute to certain sleep problems. So, for example, the heavier that you are, the more likely you are to experience obstructive sleep apnea or an intermittent collapsing of the upper airway during sleep. So if somebody loses weight, then you would expect the weight loss and isolation to positively affect their sleep. So it might not be an effect of the ketogenic diet per se in that instance. It might be the weight loss that follows from the ketogenic diet, if that makes sense. So lots more work is necessary to work out the effects of that. But with that said, I know lots of people anecdotally report that they've gone on a very low carbohydrate diet, whether it's a carnivore diet or a ketogenic diet or simply a low carb diet, and they feel they sleep better and they haven't lost weight or anything like that. And that could be the result of lots of different factors. And I don't want to dismiss those reports because it's interesting, but based on what I've seen so far, there's not really strong evidence to indicate that that type of approach is going to profoundly affect sleep. Now, with that said, it's clear that certain dietary constituents do influence sleep. And I could speak about lots of different things now, but when people go on low carbohydrate diets, often one of the things that happens is they consume a lot more dietary protein than they previously did. And that, of course, is good for all sorts of things, primarily body composition. People consume more protein, they feel more satiated, they eat less. The protein's important to the retention of fat-free mass during weight loss. It's conducive to a positive skeletal muscle protein balance. So all those things are good, of course. But some of the work that's looked at higher protein diets and sleep quality report that higher protein diets seem to negatively affect sleep quality. And the mechanisms that are cited for that are quite different between studies. And I think the mechanism that makes the most sense to me is that when people consume more dietary protein, they typically consume more creatine. And creatine is something that people often consume as a dietary supplement, as creatine monohydrate. They might take 2 to 5 grams a day, every day, in order to increase their skeletal muscle phosphocreatine stores. And that in turn seems to improve exercise performance, particularly during strength and power exercise, repeated bouts of that type of exercise. It seems to positively affect skeletal muscle adaptations to resistance training, such that people grow muscle a little bit faster, get stronger a little bit faster. But also it's been looked at in relation to other types of exercise. So intermittent sprint exercise, for example, and endurance exercise. It seems that taking creatine monohydrate might boost muscle glycogen stores a little bit, which could positively affect endurance exercise, but also it has osmotic properties, which can influence hydration, which might benefit things like exercise in the heat. So it has all these positive effects on exercise. But one thing that happens when people take creatine is that it also boosts brain phosphocreatine stores. And that's really interesting, because what can happen is when people's brain phosphocreatine stores are a bit lower, they potentially could experience certain effects. So maybe they feel more sluggish. Maybe their mood's not quite as high as it might otherwise be. And interestingly, giving people who have treatment-resistant depression, so people, for example, who haven't responded positively to SSRI drugs, creatine monohydrate tends to actually improve their mood. And not only that, if people undergo sleep loss, so if, for example, Gary, you were completely deprived of sleep tonight, and then tomorrow we gave you creatine monohydrate, then we might find that your physical performance is better than it would have been without the creatine monohydrate, but also your mood would be slightly higher, and some measures of your executive function, so your ability to plan and carry out and monitor your behaviors that are directed to achieving a particular goal, would be slightly better too. Now, when you take creatine monohydrate, if your brain phosphocreatine stores are higher, then what's going to happen is you can recycle the ATP in your brain at a faster rate. And so with prolonged wakefulness, what typically happens is the ATP is broken down, and the eventual product of that is free adenosine. But if you take creatine, then more of that adenosine is going to be phosphorylated. And what that means is that less adenosine accumulates in the brain with prolonged wakefulness in people who take creatine monohydrate supplementation. And adenosine, because it's basically a signal that our energy stores are declining, adenosine stimulates sleepiness. So if you take creatine and you're reducing that increase in adenosine over the day, then you have a weaker sleep promoting signal. And as a result, people might find that they don't sleep quite as long when they take creatine monohydrate. And they might also find that their sleep is a bit shallower. So to circle back to the dietary question, if you have somebody on a very high protein diet, then they're going to be consuming more protein from their diet. They're going to be boosting their brain phosphocreatine stores in response to that. And then with those higher brain phosphocreatine stores, they might find that they take longer to fall asleep and sleep slightly less deeply, and also perhaps sleep slightly shorter. But that's based on studies of non-human animals. So it's just mechanistic right now, but that would be my contention there. So some other things to consider are that certain other things in our diets seem to influence sleep. And people have primarily looked at plants specifically. So for example, if you give people high glycemic load carbohydrates in the few hours before bedtime, there's some evidence that that might help them fall asleep a bit faster. And the reason is that when you consume those types of carbohydrates, you will produce a strong insulin release from your pancreas in order to dispose of those carbohydrates from the bloodstream. And what will happen is the insulin will help drive those carbohydrates into your skeletal muscles, but it will also drive certain amino acids into the skeletal muscles, so the branch chain amino acids specifically. And as a result, there'll be fewer of those in the blood. And tryptophan is an amino acid that's a precursor to melatonin. And melatonin is a signal of darkness in our bodies that has weak sleep promoting effects. And so when somebody consumes those carbohydrates, they drive more branch chain amino acids into their muscles, which means that there are fewer branch chain amino acids in the blood to compete with tryptophan for entry into the brain. So more of the tryptophan in the blood goes into the brain, and potentially you synthesize more melatonin and thereby sleep a little better or fall asleep a little bit faster. So there's some evidence that carbs late in the evening might help people fall asleep a little bit faster. And then there's been some work looking at specific foods and their influence on sleep. So it's slightly esoteric, but people have looked, for example, at consuming kiwi fruit each day and found that that tends to improve sleep quality. People have looked at beef tomatoes and found that consuming beef tomatoes will improve sleep quality. And there's probably been the most research on tart cherry juice. And again, some people report that that will tend to improve sleep quality. And then, of course, there's an array of different herbs and so on that have been tested in relation to sleep. So that could be things like valerian and lavender and lemon balm, all sorts of different compounds. So basically, to summarize, if you go on a low carbohydrate diet and your general health improves, and if you lose weight and you're overweight at the start, then I would expect your sleep quality to improve. If you're already lean, then I would expect if you go on a low carbohydrate diet and increase your protein intake, then perhaps your sleep would fragment a little bit, but there isn't good research showing that. That's just hypothetical. And then the other fact to consider is just that if you've gone a low carbohydrate diet and your consumption of certain plants declines, then you might not have some of those sleep promoting effects from those plants. But of course, there hasn't been much work looking at the types of foods that people consume on very low carbohydrate diets and their influence on sleep. And there is a little bit of work showing that some of those foods might positively influence sleep. So, for example, some of the peptides in dairy proteins could positively affect sleep. And just as a funny example of this, there's been a little bit of research looking at milk, which is collected at different times of day from cows. And if you collect milk from cows at night, then there's melatonin in their milk. And consumption of that nighttime milk might promote sleep more than consumption of daytime milk, for instance. So that was quite a long-winded answer to your short question. But basically, I'm not really sure. It's a really interesting question. It's a difficult thing to study. It hasn't necessarily been studied that well. And the other thing, of course, is that people's pre-diet perceptions of what's going to affect their sleep will probably strongly influence their responses to it. So if I began a carnivore diet tomorrow and thought to myself, this is going to be great for my health, then it's much more likely to be great for my health than if I began it thinking, oh, I'm going to begin that carnivore diet and I'm going to get bowel cancer because I'm not consuming any fiber or whatever. Hope some of that makes sense, Gary.
Oh, definitely it does, and fantastic answer for for not being prepared there. I mean, I'm just trying to. I had to take some notes down on some of those interesting points that you brought up, because with the creatine, that's also an interesting one, because that is touted as good for people who are over the age of 30 for brain health, just to take it. And I mean, you explained it eloquently there, and I'm just thinking, then, does it mean actually to be able to get the benefit, because we want that higher cognitive function benefit from taking it, but actually from a body clock circadian biology thinking, we actually should be taking that early in the day so that maybe it doesn't affect our sleep later on that day. So we get the best of both worlds, hopefully.
Yeah, I think that's exactly right. And that's probably the primary reason I find creatine so interesting. In every other instance that I can think of, when you reduce the amount of time that somebody spends in bed or the amount of time that somebody sleeps, bad things happen. So whether you're looking at their metabolic health, maybe you're looking at their glucose disposal, maybe you're looking at their blood lipids, maybe you're looking at measures of cardiovascular health, such as blood pressure, whatever it is. If you restrict their sleep, those things tend to get worse. If you look at their brain function, the same thing happens. Their attention tends to wane when they get less sleep. Their mood tends to deteriorate over time, and their risk for neurodegenerative diseases tends to go up. And whether that could be whether somebody gets less sleep or whether their sleep is disrupted in different ways. But when they take creatine, even though based on this preclinical research, it seems that people are likely to sleep a bit less, creatine seems to benefit pretty much everything that has been measured so far. So exercise performance, some markers of metabolic health, some endocrine measures, for example, but then also brain function. And as you say, creatine seems to have some neuroprotective properties. There's been lots of preclinical research looking at whether it influences responses to concussions that are induced by various stimuli, for instance. And also people are interested in whether it could protect against things like Alzheimer's and Parkinson's. So what I would say is that if there's one thing that people should take during periods of time when they're not going to get as much sleep as they would like to get. So maybe, Gary, you decide that tomorrow you're going to begin a startup business and you need to work around the clock initially just to get the thing off the ground. I would say take creatine during that time, definitely. That would be my first port of call. You can use caffeine to a similar effect. And caffeine's interesting because caffeine blocks the ability of adenosine in the brain, which I mentioned earlier, which promotes sleep, to interact with its receptors, and it blocks all of the different subtypes of adenosine receptors, whereas creatine reduces the accumulation of adenosine. So in that way, you'd kind of expect them to be synergistic, but caffeine, of course, has some negative effects. So it tends to increase people's stress levels. They're physiological markers of stress too, cortisol, epinephrine, norepinephrine, and so on too. So you can use caffeine, but I just think that creatine is more likely to support your general health. So I think most people probably should take creatine. It's probably a good idea for them. If you've got somebody who's having a really hard time with their sleep and they just want to improve their sleep quality, then I would probably say avoid creatine. But if you do take creatine, then I do think the best time of day to take it is likely with breakfast. And you want to take it with food because there are certain things in a mixed macronutrient meal that would help with creatine uptake. Carbohydrate specifically tends to improve creatine uptake. Sodium might as well. And also physical activity does. So if you get outside and you go for a walk in the morning or whatever, first thing, then if your breakfast follows, that brief bout of exercise might help improve your body's creatine uptake. So yes, take it first thing in the morning. I'd say that if you're using it acutely to cope with sleep loss, then you might want to take a slightly higher dose. And that might be something like 0.1 grams per kilogram of body mass. But otherwise, if you're taking it in the long term for general health or to support adaptations to exercise training, then you probably want to take something like 3 to 5 grams a day based on your body mass. So if you're 100 kilos, you might take 5 grams, but if you're 60 kilos, you might take 3 grams.
Great. And what you're just talking about there too, we're taking it in the morning. It just gets me thinking about body clock stuff where I read about all the time as how important it is to have breakfast in the morning if you're looking to reset your body clock too. Do you also follow that thinking?
Yeah, God, I could give you a long answer on this one. I'll try. I'll try not to. So there's been a lot of research only in the last few years on this subject of chrononutrition. And chrononutrition is simply the reciprocal relation that exists between your diet and your body's clocks. And these so-called clocks produce biological rhythms in the absence of external time cues like the light-dark cycle or variation of temperature or variation of feeding and fasting. And the purpose of these biological rhythms is basically to optimize biological processes according to time of day. And in short, in a circadian system, and the circadian system is basically those biological clocks that regulate biological rhythms of about 24 hours or so, such as the sleep-wake cycle. In a healthy circadian system, the circadian system promotes wakefulness and physical activity and eating behavior during the biological daytime. And then during the biological nighttime, which is when melatonin is high and when we've got a strong urge to sleep, it promotes rest and sleep. And that's the time of day at which we should be fasting. So our bodies are primed for food intake during the biological daytime. And then within the biological daytime, it seems that consuming a greater proportion of our calories and of specific nutrients at certain times of day might be conducive to good health. And to this end, some people have been looking at so-called time-restricted eating. Sometimes it's called time-restricted feeding, but I typically refer to time-restricted feeding in the context of studies of non-human animals. So time-restricted eating basically entails consuming all of your calorie-containing items in a period of 12 hours or less each day. And when people go through this type of time-restricted eating, there's some evidence showing that especially if they have poor metabolic health to start with, they experience a range of different improvements to their health. And within this category of time-restricted eating, there's been some work looking at so-called early time-restricted eating, which basically is using time-restricted eating, but then assigning that eating period early in the biological day. And the most relevant studies to this have been done by researchers at Pennington. And the first of these came out in 2018 and was led by Courtney Peterson. And what they did was they basically took adult men who have pre-diabetes through either early time restricted eating or another condition in which they spread out their calories each day. And everyone went through both conditions. Each of the conditions lasted 5 weeks or so. And during the early time restricted eating period, they consumed all of their calories between about 8 a.m. and about 2 p.m. So it was a 6-hour caloric period. And then during the other control period, they consumed all between 8 a.m. and 8 p.m. So it's a 12-hour condition. And what they found was that compared to the control condition, the early time restricted eating led to improved insulin sensitivity, lower measures of oxidative stress, which over time you'd expect to lead to slower aging potentially. But then also a dramatic drop in morning blood pressure. And it was about 10 millimeters of mercury, which is a really big effect. It's comparable to the effect of antihypertensive drugs, such as ACE inhibitors. So that was some work showing that when you control for the number of calories that people are consuming, and you can control things like the proportion of calories coming from carbohydrates and protein and fat respectively, early time restricted eating leads to a bunch of positive effects. And then they subsequently published 2 more papers last year looking at a much shorter term intervention. So these studies just looked at the effects of 4 days of early time restricted eating compared to 4 days of this type of control condition. And basically they found that after early time restricted eating, average blood sugar levels were a bit lower, but also interestingly, appetite regulation was slightly better, such that people didn't experience the types of big swings in their appetite that they otherwise would have done, which is interesting because I think superficially most people would think that if they're finishing their final meal at 2 p.m. or 3 p.m. in the evening, they're going to be ravenous. But they didn't really find that. One thing to mention here, though, is that their studies have shown that some people did report adverse effects. So, for example, I think 1 or 2 people had headaches and experienced some nausea and some vomiting, which is probably just an adaptation to that new eating pattern. It might have been entirely unrelated. But in contrast, the studies that have allowed people to self-select their own time-restricted eating period haven't reported any of those adverse effects and have still reported some positive effects. So, for example, Sachin Panda contributed to a recent study, which I think was led by Pam Taub at UCSD, and they looked at adults who have metabolic syndrome. And they basically got them to go through a 10-hour time-restricted eating period for 12 weeks or so. And what they found was that self-selected 10-hour time-restricted eating period led to all sorts of improvements in their health, including things like weight loss, improved diet regularity, which seems to independently be important to metabolic health. People reported more often feeling rested after the time-restricted eating intervention. But then also they found improvements in some blood lipids, in blood pressure, and not only did they lose weight, they also, of course, lost some fat mass and their waist circumferences declined too. They didn't find any effects on blood glucose control, but their results indicated that had they had a larger sample size, they likely would have done. And I suspect that that effect is there. It's just that their study was underpowered to detect that. So basically, those studies indicate that this type of time-restricted eating seems to be good for metabolic health of people, especially if they have poor metabolic health to begin with. And there are then a few different levels of complexity within that, which people can leverage to boost the beneficial effects of time-restricted eating that they experience. So one of them is front-loading their consumption of carbohydrates within the eating period. And this doesn't apply to people on a carnivore or ketogenic diet so much, but if you do consume a substantial number of calories from carbohydrates each day, then there's been some work, I think the best of which is probably by Danielle Jakubovics, showing that when people assign a greater proportion of their daily carbohydrate intake at breakfast, they will experience all sorts of positive effects that are, again, independent of the total number of calories they consume. So the first study they did to this effect was in 2013, and they had two groups of overweight or obese women who for 12 weeks went through a weight loss diet, same number of calories in both groups. Only difference was that one of the groups had half their calories at breakfast and the other group had half their calories at dinner. And after 12 weeks, the group that had half their calories at breakfast had more than twice as great an increase, had more than twice as much weight loss, experienced more than twice as much loss of centimeters off their waists, and had greater improvements in their blood lipids too. And then more recently, they've done some work looking at people who have type 2 diabetes. And again, they've compared two different conditions, one in which people consume about half their calories and half their carbohydrates at breakfast, and the other in which their calories and carbohydrates are more distributed throughout the day. And long story short, they basically found similar effects. Again, independent of calorie intake, people lose more weight when they assign more of their calories and carbs at breakfast. But not only that, they found very big differences between the groups in terms of their blood sugar, such that if you look at the group that had more of their calories and carbohydrates at breakfast, over the intervention, they spent, I think, about 83% more time within the normal blood sugar range, the healthy blood sugar range, than the group that distributed their calories and carbohydrates more. So to circle back to what I started with, using this type of consistent, regular 6 to 12 hour caloric period each day seems to be good for metabolic health. And then within that, putting more of the carbohydrates and calories early in that period seems to be good. If you're on a very low carbohydrate diet, then my guess, again, hasn't been well studied, my guess is that it makes more sense to put more of your fat early in the caloric period than late in the caloric period. And then, as I alluded to earlier, diet regularity seems to be important. Ian McDonald's done some nice work at this. If you look at young women and they go through two conditions, one in which they consume a fixed number of meals each day and another condition in which they consume a varying number of meals each day, such that on average, the number of meals are the same. Again, calories the same, carbs the same, fats the same, proteins the same. The regular condition leads to improved appetite regulation. The women burn more calories after their meals, and they experience greater improvements in insulin sensitivity and blood lipids too. So diet regularity is important. And then also within each dietary event that somebody goes through, the sequence in which a person consumes foods might be important to their metabolic responses to consuming those foods, such that when people consume carbohydrate-rich items last within a meal, their blood sugar responses are dramatically lower than when they consume them first. And that's why it makes sense to have sort of a Mediterranean type pattern in which you have maybe a salad with some fish first, followed by a main, because that salad at the start is going to reduce your blood sugar responses to the main meal subsequently. And the size of that effect is very big again. It's comparable to hypoglycemic agents. It depends on which particular metric of glucose responses you look at. You can look at incremental area under the curves. You can look at mean blood glucose over a period of time after, but they all show sort of 30 to 60% differences between carbohydrate consumption first and carbohydrate consumption last within the event. So consuming carbs last within the meal seems to be pretty smart too. And then, of course, people work shifts too. So if you're a shift worker and you go through rotating shifts, then it seems that if people could stick to a fixed or regular pattern each day, that would be good for their health. And again, confining that to the daytime probably would be a good thing for most people, but practically that's really hard. So if you feel the need to consume a snack at night, and most of them will, if you look at when people consume calories in shift workers versus non-shift workers, typically the shift workers will spread out their calorie consumption more than non-shift workers. So if they consume calories during their shifts, then they just want to have a snack which is relatively small. So if they have a snack which provides about 10% of their daily energy intake versus about 30%, it seems that they'll suppress their appetite to a similar degree to the larger meal, but they're less likely to experience digestive discomfort. Their blood sugar responses following the snack are much lower. And also, the snack could, in some instances, have some positive effects acutely on some measures of cognitive function. So how alert they feel during the shift. And lots of shift work jobs are very important to people's safety. So that's actually a really big consideration. So just say if you're a shift worker, then have a small snack at night, make it satiating, make it easy to digest. I'd probably just pick something which is high in fiber and high in protein. And that way it's more likely to be good for your body composition, but it will also be nice and filling too. So those are a few different things to consider. I'll add one more thing, and that is that stimulant consumption is, of course, a big consideration for lots of people. And people vary massively in how they respond to consuming caffeine. But with that said, if I was going to just offer a generic guideline, I'd say you probably want to cap your intake at about 3 milligrams of caffeine per kilogram of body mass per day. If you look, for example, at the sports nutrition literature, then it seems that at that dose, people will experience almost all, if not all, of the benefits of consuming caffeine versus consuming a higher dose, like 6 milligrams per kilogram. And if you cap your caffeine intake there, then the other thing to consider is the timing of the caffeine intake. And there's been some work comparing what happens when people consume a fixed amount of caffeine at bedtime versus about 3 hours before bed versus about 6 hours before bed. And caffeine intake at all of those different time points seems to negatively affect sleep. So the earlier the better. You probably don't want to have it immediately on waking, because at that time your cardiovascular system is more reactive to stresses or to stimuli that can lead to a stress response. Caffeine, of course, will increase your body's production of certain stress hormones. So I'd say you probably want to wait an hour or so after you wake up before consuming caffeine. But then you probably want to consume your caffeine shortly after that. Early the better. The more caffeine that you consume, the earlier you want it to be. And the alternative is that you can just have very small quantities of caffeine, which are more spaced out. And that type of approach can be very useful during periods of time when somebody has to stay up for a long period of time and has to stay relatively alert. So hopefully that answers your question.
Sorry, it does.
It's very long again.
Again, very well done. I mean, just so many things I could pick out there individually, but it sounds like time restricted eating earlier in the day can potentially have a benefit. Again, if we're looking at this individual response, that people are willing to test it, like have a shorter eating window. And I think this leads into when people start go into the world of fasting or intermittent fasting. So they naturally are working on these restricted eating windows. It just, even they're playing when you eat it. And something I've noticed too, speaking to so many people who've had positive responses from changing the way they eat, is even going less meals a day, like even down to OMAD, 1 meal a day. And it's got me just thinking, is the benefit there just because you've restricted your window so tightly, and then your body has a different metabolic response out of all the other times that you're not snacking or eating. And you've spoken so much there about the insulin sensitivity, and I think anyone who's listening to this from probably a low carb or ketogenic point of view, from a metabolic improvement, they're trying to improve their insulin response, because that's what's talked about so much in the community too. So it's interesting to hear that maybe that is a unstudied benefit, that by eating that certain way, you're improving your insulin sensitivity, reducing your insulin resistance, and that potentially can lead into better sleep quality too. And it maybe with that route, I'm thinking.
Yeah, so a few different things to pick up on there. So first, with respect to insulin sensitivity, I mentioned earlier that our circadian clocks influence all sorts of different things with respect to how we metabolize foods. And one of them is, of course, how we dispose of glucose. So Frank Shear did some nice work on this a few years ago, basically finding that during the biological morning, which would be around 8 a.m. for most people, people's glucose disposal is about 17% higher than it is during the biological evening at about 8 p.m. And that is probably the product of clocks in some of our different tissues. So, for example, adipocytes, fat cells have their own clocks, which have an intrinsic rhythm and insulin sensitivity, but also some of that will relate to things like pancreatic function. And another factor is our body's production of melatonin. So melatonin seems to inhibit glucose-stimulated insulin secretion, such that if you consume lots of carbohydrates when your body's producing melatonin, for a given amount of insulin that your body produces, your blood sugar will swing more in response to that particular dietary event. So that's one factor there. Another thing that you mentioned is time restricted eating and sleep. There hasn't been too much stuff on this yet. So I mentioned in Pam Taub's recent paper, they found that in this very simple question that related to how well rested people feel each day, the time restricted eating intervention improved that particular index. But they also looked at the Pittsburgh Sleep Quality Index, and they didn't find any change in that. There's been a little bit of work looking at what happens when you change the size of the final meal each day and its effects on sleep and overnight heart rate variability. And when people consume a smaller proportion of their daily calories late in the day, it seems that their overnight HRV is higher. And I know lots of people listening to this will self-identify as being biohackers. And they might have noticed that when they consume lots of food at night, their overnight pulse rate variability is assessed via an Oura ring, for instance, will be worse. So that's another factor too.
And yeah, I mean, I've noticed that I've got an Oura ring, and Oura always tells me, hey, even your average resting heart rate is higher. And did you eat a late meal? Because that would be an indicator of what caused that. And wine will do that too to me, I noticed.
Yeah, wine unfortunately will do that to everyone. To be honest, the best time in which to consume wine is definitely breakfast. it's just not the cultural norm, unfortunately. But I haven't mentioned alcohol. Alcohol is disruptive to the circadian system at multiple different levels. So it's particularly disruptive to the circadian clocks in the gut, for instance. And we have rhythmic change in all sorts of different aspects of gut function, from the gut microbiota to the motility of the gastrointestinal tract itself. So that's one way by which it will disrupt our body's clocks. But also with respect to sleep specifically, people tend to fall asleep a little bit faster after consuming alcohol, and they spend a greater proportion of the early sleep period in the deeper stage of sleep. But then later in the sleep period, their sleep tends to fragment. And we've all experienced this. You have a few drinks in the evening, and then the next morning, so early in the morning, when you want to just be sleeping soundly, you just keep waking up. And sometimes it's to pee because alcohol has diuretic effects, but then other times it's unrelated to that. The other thing is that alcohol is a muscle relaxant. So for people who snore, which is probably something like a third of adults, alcohol will exacerbate that, and it will exacerbate sleep apnea in people who have that particular breathing disorder. So that's a problem too. And then when you assess people the day following alcohol consumption, various different cognitive performance measures will be impaired too. Again, that's perfectly obvious to people, I know, but there is research showing that. The other thing is that alcohol can lead to tolerance. So I think historically, at least, people once used alcohol as a sedative. They thought, oh, I'll have a nightcap, it'll help me sleep. When you remove the alcohol in subsequent days, their sleep is likely to deteriorate in response to the withdrawal of that stimulus, because alcohol is quite habit forming. So you might have some change in various different things that will influence your responses to alcohol, and that will exacerbate any existing sleep problems. So unfortunately, booze is a bit of a killer too.
Mm-hmm. Well, I'm just thinking of, I mean, there's so many good things we've touched on. Another thing I actually wanted to ask you there was just coming back to the benefit of having some carbs later in the evening. There, that was interesting because what were the, if just to give people some practical examples, like what were the foods that you might say that someone could have, and also just the volume. So it's not like have a big plate of something. It's actually even just one or two of something, maybe an hour or two before you go to bed, potentially could help you have a better night's sleep.
So I'm really glad that you picked up on that, because I didn't really close a thought that I had related to that. Because with most of these things, there's a trade-off. So, for example, you go on a high protein diet and your body composition improves in response to that. Your appetite regulation improves in response to that. Independently, the high protein diet, based on what we know, might slightly interfere with your sleep. So the question is, what are you optimizing for? And for most people, I'd say go on a high protein diet. The overall positive effects of that are likely to more than outweigh any small negative effects of it. And so I mentioned earlier that if you look at the studies that have been done on the distribution of carbohydrate intake, then putting more of your carbs early in the day seems to be good for metabolic health, which seems paradoxical based on the data showing that if you consume a high glycemic load bolus of carbohydrate late in the day, then you're likely to sleep better. If you sleep better, you'd expect your next day glucose metabolism to improve in response to that. So there's a trade-off there between how well you want to sleep and how good your overall metabolic health is likely to be. Potentially there's a trade-off there. That needs to be disentangled, I think. But I suppose what I would say is that one important factor to consider is the timing of exercise, which we haven't really touched on, but our bodies in general are very well prepared to exercise in our biological afternoon. So maybe at 5 p.m. or so for most people. Body temperature is highest at that time, and our joints are most supple at that time. They're oiled better than at other times of day, so to speak. And as a result of some of those changes, we tend to be strongest and most powerful that time of day. The best time of day for endurance training seems to be quite different between different people. But if you were truly trying to optimize everything based on when our body's clocks best prepare us for different activities, the best time to do strength and power exercise would be in the biological afternoon. And if you exercise then if you consume carbohydrate after the exercise, then your metabolic responses to that dietary event will be improved by the exercise. So all of those muscle contractions, for instance, will increase non-insulin mediated glucose uptake. So any carbs that you consume are more likely to be shuttled into muscle glycogen than they are into adipose tissue. So one way of getting around that circadian rhythm in insulin sensitivity and glucose disposal is by exercising in the afternoon. And then you can consume carbohydrates after the exercise, and the carbs that you consume are likely to go where you want them to go. And then they could also positively affect sleep too, potentially. So that's one way around it. But let's say that somebody's sedentary, they're struggling with their sleep, and they think, well, it's interesting that a high carbohydrate meal late in the day could positively affect my sleep. The studies that have looked at that specifically have tended to look at white rice. And the first of these that comes to mind was done in 2007 by Afagi. And that was a high glycemic load or high glycemic index white rice. And the amount that's appropriate for people will be dependent on the person. But you might just try by having a relatively small quantity of a carbohydrate, such as white rice, with the final meal of the day. Personally, just anecdote, I find that having white rice at dinner helps me fall asleep faster. Strangely, I'm this is bizarre, and I hope that people don't take this as some sort of advice or whatever. But strangely, I'm convinced that it boosts my testosterone the next day. So I won't go into details, but there's something there. so so I think having a high glycemic index carbohydrate with the final meal of the day, a small quantity of it, is something that people can try, especially if they're struggling to fall asleep quickly. But if you are interested in optimizing your blood sugar regulation, then you can have the carbs later in the day. But if you then want to reduce any negative effects of doing that, I would say the best time of day would then be to exercise relatively late in the day. Not too late. If you do very high intensity exercise within, let's say, 3 hours of your planned bedtime, then I think it could interfere with your ability to fall asleep and sleep well. So the higher the intensity and the longer the duration of the exercise bout, the more damaging. So running is more damaging than cycling, for example, to your muscles, the more likely the bout is to interfere with your sleep. But if you do some moderate exercise 3 hours or so before bedtime, and then shortly after that, you have your final meal of the day, some carbohydrate in it, not too much, enough protein to help you adapt the exercise, that's a good way to go.
Mm-hmm. Yeah, again, I love that individualism that's coming out in this. Hey, experiment, test it out. Maybe a little bit of white rice increases your testosterone. I know what you're alluding to there. So, yeah. Greg, I think I've teased out quite a bit in the nutrition side. I can see we've been talking for an hour here. There's so much more I could probably ask you with sleep hacking and optimizing. I mean, I saw in one podcast or somewhere that you talked about even why we should wear socks or something like that. And I mean, there's a whole bunch of other stuff I could get you on. So I think I might need to get you on for another episode to talk about some of these other things outside of nutrition. But if someone wants to maybe follow you or catch up with you, keep up to date with what you're doing, where are the best places for them to do that?
Yeah, best places are, I'm on Instagram and Twitter. My handle now is at Greg Potter PhD. And the reason it's at Greg Potter PhD is I was looking for a URL for a website, which I just made. And that was the only one that was really available. gregpotter.com is taken. So I'm at Greg Potter PhD on those. I'm at Greg Potter PhD on LinkedIn. And I now have a very, very rudimentary website, which is gregpotterphd.com. And over time, I'll look to add some useful information to that. But at the moment, it's basically just a bio. There is a resource section in it. So over time, my plan is, of course, to put lots of useful content, especially related to the types of topics that we've been discussing today, up on there. And I'll build that out over time. But those are the places. And if anybody has any questions, then please do feel free to reach out to me.
Oh, yeah. And I think people are going to do that, especially when it comes to, as you said, with all this nutrition stuff. It's amazing where, okay, so it's one thing here, but there's another thing here. And so just what we were talking about with the carbs. I mean, so many great pieces that you could piece out there. So, but I just want to say thank you for all those knowledge bombs. I really enjoyed that. So thorough and so entertaining. And I'm looking forward to meeting you in person next week in London.
Yeah, absolutely. Yeah, thanks, Gary.